Now, simple linear regression is used to predict y, that is the quantitative response, on the basis of predictor x, assuming a linear relationship between x and y. So mathematically, it is given by y is equal to beta naught plus beta 1 into x plus epsilon. Now, beta naught is an intercept, beta 1 is the coefficient, and epsilon is the error here. Now we have 4 important steps here. We first estimate the coefficients, then we check if there is a relationship between x and y or not. Then we'll see how do we assess model accuracy, and finally we can make prediction. So we'll see each of these steps one by one. So the first step is to estimate the intercept and the coefficients. So for this purpose, we will use ordinary least square method. So let's say we are regressing sales onto cost incurred on TV ads. We will write sales equal to beta naught plus beta 1 into TV, which is basically the cost incurred on TV ads. Now if you see in the graph shown here on the right hand side, we have our blue line, which is the regression line that has our predicted values, and the red dots, that is the actual data points. Now the difference between the actual values and the predicted values is called residuals. It is given by yi minus yi hat. And then when we square it and add the residuals for all the points, it is called a residual sum of squares, that is RSS, and it is given by E1 square plus E2 square plus E3 square up to En square. So ordinary least square estimate finds the coefficient with the least residual sum of squares. Now the second step is to check if there is a relationship between x and y. So what if our y does not depend on x at all? So in this case, we will check the null hypothesis as beta 1 is equal to 0 and alternate hypothesis as beta 1 is not equal to 0. So in this case, we will check the null hypothesis as beta 1 equal to 0 and alternate hypothesis as beta 1 not equal to 0. Once we have checked it and concluded that there is a relationship between x and y, then we can also calculate standard error for the coefficients to know the accuracy of our estimates. Recall, standard error tells us how wrong our estimate would be on an average. So we use standard error of the coefficient to measure the precision of the estimate of the coefficient. And once we have standard error, then we can also use it to create confidence intervals, and so on. Then in the third step, we will check the accuracy of our model. So there are two measures that we use. First is RSE, which is the residual standard error, or we can use MSE as well, which is mean squared error, and R square. Now RSE is the average amount response will deviate from true regression line, and it is given by square root of RSS divided by n minus 2. Here n minus 2 is the degree of freedom. Now we have already seen what RSS is. It is the squared sum of residuals and tell us the amount of variability that is left unexplained after performing the regression. RSS is given by E1 square plus E2 square up to En square. And what is E here? E is the residual. And we know that residuals is the difference between actual value and the predicted value. It is given by yi, which is the ith value, minus y hat I, which is the ith predicted value. We also have MSE, which is mean squared error. Recall we studied the cost function in the previous video. So MSE is given by RSS divided by n. So we can either use RSE or MSE. But the lower the value of RSE or MSE, the better will be our model. Now RSE is an absolute measure and it is measured in units of y. So it is not always clear what constitutes a good RSE. Means how big or small the value should be, beyond which it becomes alarming. So to tackle this problem, we have R square. R square takes the form of proportions and it will lie between 0 to 1. And it is independent of y. So by definition, R square is the amount of variability explained by the model and is given by TSS minus RSS divided by TSS. Now TSS is the total sum of squares, which is the amount of variability inherent in the response. That is variability before regression. And it is given by the summation of yi minus average of y. Then TSS minus RSS is the amount of variability explained by regression. Hence, when we calculate R square, which is given by TSS minus RSS divided by TSS, it means it explains the proportion of variability. That is, R square of 0 means nothing is explained, and R square of 1 means 100% of the variability is explained by the model. Now there is a problem with R square, which is also a problem for RSE. That is, they are variable sensitive, which means R square will increase and RSE will decrease if we add more variables, irrespective of that variable having an effect on the model or not. Therefore, we need a more robust statistic which is independent of the variables. So for this purpose, we use adjusted R square. Now I am skipping the formula here, but just understand that adjusted R square is a modified version of R square that is adjusted for the additional variables. So addition of variable will not have any impact on adjusted R square. So this is a more robust statistic. Now our final step is to make the prediction. So once we have fit the model, it is easy to predict the response by just plugging in the coefficients and the predictors in the regression equation. Now we will not be calculating the coefficient beta. Instead, we will be calculating beta hat. Because beta hat is an estimate of the actual coefficient, and the inaccuracy in the estimate is due to reducible and the irreducible error. So to address this problem, we will develop confidence interval and prediction interval. Now let's understand what is the difference between the two. So let's say we have sales data of our cars based on the expenses incurred in advertisement in different media, such as radio, TV, newspapers, etc. Now we have this data for different cities as well. So here we can use confidence interval to average the sales of these cities, which means we can say that for a 95% confidence interval, the average sales of these cities will be between 950 to 1170. That means 95% of the time, average sales of these cities will be between 950 to 1170 units. Now on the other hand, we can use prediction intervals for a specific case for a prediction. We can develop prediction interval for predicting sales of a particular city, which means for a 95% prediction interval, we will say that 95% of the times sales of city will be between 820 to 1278. And remember, prediction interval will always be greater or have a larger range than confidence interval. So that is the basic difference between PI and CI.